Hey guys, in this video we are going to cover something called logarithms, and we're going to start with a warm-up here. So what I want you guys to do is use your rules for exponents to evaluate each of these expressions that are on the board. Pause the video to do that and then come back to check your answers. Okay, so there's a couple of rules that you need to use, and I'm going to just review those really quickly. If you have a base a here to a power of a that's rational, so you have a fraction in the exponent, you can rewrite that in radical form, which is sometimes what you'll need to do in order to evaluate. Radical form involves a radical, that's why it's called radical form, and that's what a radical is that symbol right there. Whatever's in the denominator is going to go here in this is called the index. The denominator will go in the index, and then the base stays here, and then the whatever's in the numerator will be the what the base gets raised to. You can write it like that. You can also write it like this, where you take the nth root of a first and then raise it to the power of n. So that is a rule that you'll need to use. Also, if you have a negative exponent, when you have a negative exponent, when you're trying to evaluate something, you're going to want to write it so that it's got a positive exponent. And to do that, this is a fraction. Every number can be written as a fraction. You put it over 1. But to convert it so that it has a positive exponent, what we're going to do, we're going to drop it into the denominator, and then it changes the sign of the exponent. So if it was negative, it becomes positive. If it was positive, it would become negative when you move it across that fraction bar. So these expressions here, the 36 to the 1/2 power is the same thing as 36 with the index of 2. When the index is 2, where it's a square root, we don't need to write the 2 in there because it's used so commonly that we don't actually write it. It's like when you have a positive number, we don't have to put a plus sign in front of it, but if it's negative, we need the negative in front of it. You're just going to assume that it is positive if there's no sign in front of it. All right, so then 36, the square root of 36 is what number times itself equals 36, which is, of course, 6. 17 to the 0, that's another rule that you need to know. Anything to the 0 power is equal to 1. Put that into your memory banks, because it's kind of tricky to think about, but it is equal to 1. Anything to the 0 power is 1. 49 to the 1/2, again, is the square root of 49, so that's 7. Here we have a negative exponent. In order to make it a positive exponent, I'm going to drop that down into the denominator, and it becomes positive 2, so 1 over 5 to the positive second power, which is, of course, 1 over 25 when you evaluate that. Same thing with this negative exponent, 2 to the negative 3. We're going to make it 1 over 2 to the positive 3, which becomes 1 over 2 times 2 is 4 times another 2 is 8, so 1/8. So 1 over 25, 1 over 8. 27 to the negative 1/3. Again, make the exponent positive. We're going to put 1 over 27 to the positive 1/3. That 1/3 power, we can rewrite it as a radical form as the cube root of 27, which means you're looking for a number times itself again 3 times. That gives you 27. And it's 3 because 3 times 3 is 9 times another 3 is 27. Okay, so what we're going to be looking at in this lesson is logarithms. And what a logarithm is going to help us do is it's going to help us solve for exponents. So sometimes you can do it without a logarithm. Like if I were going to ask you to solve this for x, you're looking for 4 to what power equals 16. The x is in the exponent. So 4 to what power equals 16? Well, the answer would be x equals 2 because 4 to the second power is 16. So x would be 2, and that would make that statement true. Okay, so what about 4 to the x equals 12? Well, okay, we know that 4 to the second is 16, so if we let x equal 2, that's too big. If I do 4 to the first, that's just 4, that's too small. So this exponent right here is going to be somewhere in between 1 and 2, but we don't know exactly what it is. You could grab a calculator and make some guesses. You could try like putting in 4 to the, I don't know, 4, let me get out of that. If I have like 4 to the 1.5, that's too small still because we wanted it to be 12. So then you could say, okay, well, let's see if it's 4 to the 1.8. And you could do this. That's pretty close. 4 to the 1.8 is a little too big because we want it to equal 12, not 12 point something. So you could do that for all day long until you get closer and closer and closer. But we're going to use a tool called a logarithm rather than just guess and check with a calculator. Okay, so first things first, we need to, there's a form, the expression you see, b to the x, or the equation b to the x equals a, is in what's called exponential form because you have a base. So let's get some vocab here. We have b is the base, and we have it to the power of x, power, and you'll also hear me say the exponent, equals something over here, which is a. So we don't know, these are all, sometimes the numbers will be, you'll have numbers in place of b and a and x, and sometimes there'll be variables, but we can rewrite this into what's called logarithmic form. And here's how it works. You write the word log, L-O-G, which represents logarithm, and the base over here is going to be the base of our logarithm. And to write the base of the logarithm, it's a subscript, it's tiny, and just like when you write an exponent, but it's down instead, it's a subscript instead of what's called a superscript. So this is the base. And a logarithm, we're using them to solve for exponents. The logarithm is going to equal the exponent. So here's what the exponent is going to be. So that's going to be what it equals. And then this guy right here is called the argument of the logarithm. So this little b is the base. And log and a are all like the same size. The b is the subscript. This guy right here is called the argument of the logarithm. And then this over here is whatever that exponent was in our exponential form. Okay, so this is something you're going to need to be able to convert back and forth between. So let's do a little bit of practice with that. But to help you remember how to do it, you need to remember that a logarithm is equal to an exponent. So make sure you have this written down in your notes, and we can go both directions. If it's in exponential form, you can write it in logarithmic form like this, and if it's in logarithmic form, you can also rewrite it in exponential form going the other direction. So we're going to practice rewriting, and just to note to yourself, these two forms are exactly the same. They mean the same exact thing. Just like we know that 1/2 is the same thing as 0.5. They look very different, but they represent the exact same thing. All right, so try to rewrite these expressions that are in exponential form into logarithmic form, and then we're going to go the other direction. So we need to recall that I want to write it the same way. B to the x equals a. If you have an exponential form, to rewrite that in logarithmic form, you're going to write log of base, whatever this base is, of a equals the exponent x. So remember that the part that it's equal to is always going to be that exponent. So for this first one here, to rewrite that in logarithmic form, I'm going to write log for logarithm. The base over here is 4. So you're going to put a 4 here, and then 12 goes here because I know it has to equal the exponent, which is x. So you guys go ahead and do 2, 3, and 4, and then check your answers. Okay, so go ahead and check your work. If you have any questions on that, bring them to me, and we'll go over it. But you should get log for number 2, and this is how it's read. Log of, we read this as log of base 3 of 700 equals x. Number 3 is log of base 15 of 0.5 equals x. And number 4 is log of base 2 of y is equal to x. Okay, so now go the other direction. And so again, if we have b to the x is equal to a, then rewriting that in logarithmic form, it's log of base b of a is equal to x. And if you didn't catch how to read that, you might want to write this down. We would say log of base b of a equals x. Okay, so number one, you're going to look at what the base is, what's in place of the b, which is a 2, and you're going to go 2 to the 7 is the exponent, because a logarithm equals the exponent equals x. So go ahead and do those. Okay, and so you have your exponential form over here. Check your answers. Sometimes you're going to want to have things in exponential form, sometimes in logarithmic form. It depends on what it is, what part of the problem you're solving for, and we'll talk more about that down the road. One last thing I want you to write down, and that is this. If it is, so there's a logarithm that's called a common logarithm, and it's called that because it shows up a lot. It has base 10. When the base is equal to 10, it's called a common logarithm. And instead of writing it like this, y equals log of base 10 of x, we write it like this, y equals log of x, and you leave out the 10, just like we left out the index of 2 when it was a square root because it's so common. Well, this is commonly used, and so you know that if there is no base written here, that it is base 10. Okay, that's it for now, and you can go ahead and start practicing rewriting logarithms into exponential form and vice versa.